Okay, here we go. We want to do 4 problems today, and after we do these 4 problems, we then want you to be able to go ahead and work on your assignment. Number 5 looks very complicated. It is the integral of 3x over the root of 1 minus x squared dx. We're looking to find the antiderivative, and I don't know the antiderivative of that. Suppose you had this. Suppose you had the integral of 1 over the root of x dx. Would you know how to find the antiderivative of that? Yeah, x to the negative 1/2, that wouldn't be a big deal. So if we could come up with an integral that looks something similar to that, then we'd be in good shape. So let us try substitution. There are a lot of different techniques. We're going to try substitution as one of the techniques. And so what is u in this scenario? 1 minus x squared. Why does it work out that u is 1 minus x squared? Because when you take the derivative of it, you get
3x.
You do not get 3x.
2x.
You get negative 2x dx. So notice that we have an x. That's the whole idea. We wanted to come up with this x right here. This is negative 2x. I want a 3. Divide by negative 2. So I have negative 1/2 du is equal to x dx. And now what, Emma? Multiply by 3. I get negative 3 over 2 du is equal to 3x dx.
I don't want negative 3.
What's that?
Oh, kidding.
Nope. So as we look at this, I get to take the 3x dx and I get to replace that with negative 3 over 2 du. So now the 3x and the dx are gone. What remains?
1 over u to the 1/2.
Or u to the negative 1/2. So it would be 1 over the square root of u. Okay. And so I have negative 3 over 2 times, what is the antiderivative of u to the negative 1/2? U to the 1/2 divided by 1/2, which is going to be the same as multiplying by 2. Plus my constant. Notice that the 2's disappear. And we get negative 3 root of what? 1 minus x squared plus a constant. That's my antiderivative. Not too bad? A little bit tough for Jordan.
Maybe you should have been. Okay, Jordan. I'm with you.
But I'll catch up. Okay.
Yeah, thanks for noticing.
Yeah,
you're gone all the time.
I
keep it.
I sat next to you yesterday.
All right, number 6. What do you want u to be equal to? X squared plus x minus 1. What is du? I don't have a 2x plus 1 dx. So I think it's important to just pause for a second and just appreciate the what if. I think that those are questions that you kind of want to ask every once in a while if you're a math person, but let's just change this just a hair. Suppose this was the integral, and on the bottom we had x squared plus x minus 1 cubed. But on the top, instead of having 4x plus 2, suppose we have 4x plus 3. Everybody agree that in that moment, we're boxed, right? I mean, it just requires a very, very small, subtle change and all of a sudden the antiderivative, it just, you're like, shoot, what do I even do? I mean, that's challenging. Consider it the other way. Suppose I were to have you find the derivative of this. What rules would you use to find the derivative of this? Quotient rule along with the chain rule. And on the top one, you would also use the quotient rule, the chain rule. Chain rule, you look at them, you say, if I'm going to take the derivative, same method and no worries. All of a sudden, the antiderivative, it's like, what honestly do we do? I don't want to be a chicken. I don't want to be a duck, so I'll shake my butt. Okay, yeah, we got
That'd be the wall of shame.
I mean, if you want my
wall of shame. Wall of shame. Wall of shame.
Alex, you missed the picture.
Oh, well, I mean, clearly there wasn't much to miss.
Like, you're the best dressed in here. I don't know, I like the accents.
Yeah, he said that they were.
The pink looks very good.
Thank you. Really good.
Can you double check and make sure you spell your name wrong? A few names wrong.
I wasn't here during third hour. I'm sick. So I
have to dress up for my
You're not gonna
trial.
be sick next hour, right?
No.
Okay, good.
Thank you.
Are you gonna be sick 8th hour?
We're just gonna.
Yeah.
Tomorrow I will be.
Oh. This means I won't be here tomorrow.
Awesome. There we have it. We've got, I take the 2 du and I get rid of the 4x plus 2 dx. Okay, so Addie and Jordan, as you're looking at this, I see the 4x dx, which is 4x plus 2 dx, which is that.
Yeah.
And I replace it with this. So 2 du allows me to cross that off.
Oh, wait, what?
4x plus 2 dx is right there.
Yeah.
I get to cross that off and replace with 2 du. 2 du.
Oh, so you split the 2 and the D.
I put the 2 in front usually. I usually put the constant in front. Second thing is that I recognize that what's left over is this thing is u.
Oh, yeah.
So it's 1 over u cubed, so it's u to the negative third. So I just want to be clear that every time you make a substitution of du, this expresses that everything in your new integral must have u as a variable. You can't have any x's remain. Okay? So I've got that, the antiderivative of u to the negative third, u to the negative 2 over negative 2. Notice that the 2's do cancel, so you get a negative 1 over x squared plus x minus 1 quantity squared plus a constant. What if I had extra time on the test, because Mr. Gens likes to write short tests, and I wanted to check my answers? What would I do? I'd take the derivative of that, and I should get the original. Piece of cake upside down.
We really appreciate it when Gens make short tests.
Yeah. I'll show you later. So the pre-calc class, they just took their law of sines and law of cosines test. I'll show you the score distribution. So life is just feeling very good for them right now. Now they're finally getting into trig identities, like simplifying, like, well, what is 1 plus tangent squared, folks? Secant squared. Good for you. What is 1 minus cosine squared? Sine squared. What is tangent times cosine? Yep, so sine over cosine times sine over, or it's times cosine over 1, so those will cancel, you'll be left with sine. Yeah, so they're kind of in the midst of that right now. Half angle, double angle formula, stuff like that. So life is going to get a little bit more challenging for them, but yeah. So, all right, 2 more problems. What is u equal to in this situation? Is it e to the x or is it e to the x plus 1? Decide, talk to your friend about why it would be one and not the other. This is important. Ready, set, go.
You're really smart, Addie. Like missing it.
Because if you take the derivative of that, if you take the derivative of that, you don't need plus 1.
No, because the antiderivative would be plus x. To get the 1.
No, he has them both right now.
All right, let's check it out. If I take the derivative of e to the x, we get e to the x dx. And for some people, it might be happy because, like, well, I have an e to the x dx. but you used up one of the e to the x's when you chose that to be u. So how does that work? In this situation here, if you choose u to be e to the x plus 1, which is the denominator, notice that the derivative is still e to the x dx, and that then takes care of the numerator. So the bottom is the correct choice, not the top. I want to choose u to be something that when I take the derivative of it, it gets rid of what I have left. I commonly get the question from people, how do we know what to choose for u? I can't always tell you. You have to see something that will get rid of something else. So there we have it. And so we set up integral du. What does integral du allow me to get rid of? E to the x dx. So I'm left with 1 over u. What's the antiderivative of 1 over u? Natural log.
Yeah, because I was trying to figure it out one time and I was doing the wrong thing and then I figured it out. But that,
And thus, in this moment, we must consider something very important that happens within calculus. It's challenging to think about. I don't want to confuse people, but I'll just let you know. If you think of the natural log function, the natural log function looks like that. You guys all remember that, right? So therefore, the domain of the natural log function is everything that is positive. That's the domain. Agreed? So I will make a statement. You tell me whether it's true or false. I cannot take the natural log of a negative. True. So therefore, when you take the natural log of, or when you take the antiderivative, you come up with the natural log, it is customary to write natural log of the absolute value in order to maintain that it will be positive of e to the x plus 1 plus a constant. However, it is not required in this situation. In this situation, you can just write the natural log of parentheses e to the x plus 1 plus a constant. Why don't I have to write the absolute value in that situation? Yeah, e to the x is always positive. If it was e to the x minus 4, well, then that could produce a negative value, would require the absolute values. That's a technical piece that sometimes pops up on the AP exam. You might see it also pop up in your next calculus course. But you'll see me from time to time use the absolute values. Okay? Hi.
What if we always write the absolute value?
Go ahead. Just sometimes you'll wonder, is it really necessary? We have our last example. Talk with the person next to you. Decide what u should be. What should u be? U equals what? Go. Talk. Five, four, three, two, one. Notice you could choose u to be sine of x, or you could choose u to be cosine of x. And both seem very appealing because on the bottom, for example, if u is cosine of x, we take the derivative and we get negative sine of x dx. And in that moment, you're like, well, that's great because I do have a sine and I have a dx, so I'll let it be that. But it doesn't get rid of both signs. Whereas if you choose u to be sine of x, what's the derivative of sine? Cosine of x dx. And notice that if you make that choice, that is in fact a better choice. Because now, when you have cosine of x dx, that will go away. Notice I make this replacement. I have the integral, and I have du. Notice I chose to not do anything about the 4. I'll just leave the 4 there. I have a 4, and what do I have in its place of sine squared? I have u squared. Okay, so if it's a constant, you can choose to just, carry it along with you, or you could have chosen to multiply both sides by 4. It really doesn't matter. Everybody get my point? Okay, what is the antiderivative for u squared? 4u to the cubed, 4u cubed, we know that u is sine, so we have 4 sine cubed of x over 3 plus a constant. Again, if you want to verify your answer, go ahead and take the derivative. And I do go down that path. In fact, I would just encourage you, if you're ever in a moment where you're like, oh, really, that's the antiderivative? challenge yourself to take the derivative. And as you go through that process back and forth, you'll convince yourself and you'll see different relationships that you otherwise didn't see exist before. It is a good thing. Okay, so tomorrow we'll look at more challenging integral substitutions. And then on Monday, we have a very, very, very short lesson. When I say short, I'm talking about like 8 minutes. I'm sorry, on Tuesday. Okay, which means we would be ready to test next week, Friday. Okay, so it's your time to work. You got about 20 minutes. Here's what I want you to do. Open up your homework. Please look at 5.5, and right now, I highly encourage you, spend these 20 minutes. Start looking at unit 5.5 and focus on problems 1 through, I think it would be awesome if you focus on problems 1 through 24, I think would be a good shot. Okay? Some of them are going to be tougher, some are going to be easier. Go ahead and get started. I'm here to help Miss Hannah.
Yes, can I go to the bathroom?
Sure thing.
Well, I haven't been to the bathroom, so.
If you can. While
Yeah, I
you're
can.
What's that?
Serena, what are you making you for this one?
I'm getting Chinese food.
Because like if you take the